Okay, in this example, we have light from a helium neon laser passes through a narrow slit and is seen on a screen 2 meters behind the slit. The first minimum in the diffraction pattern is 1.2 centimeters from the central maximum. How wide is the slit? So notice it's a single slit, right? It's just talking about a narrow slit. So that's important. Our first single slit problem. We have lambda is equal to 633, and so that's red. So that's a red helium neon laser is a red laser. We have, this is our setup, right? And so this is A, this is our L. This right here is going to be P equals 1. And remember, single slit means that I have a bright central fringe that's bigger than all the others. And this is my first bright fringe, second bright fringe, first bright fringe, second bright fringe, right? So this is my P equals 0. This is my P equals 1. So this is if I were looking at the screen from the left. So I'm going to have my P equals 0 here. And remember, like I can kind of represent it like this, right? So when I'm talking about single slit diffraction, I'm using P to represent the dark spot. So I'm measuring from here to here. So this is going to be my Y1. So here to here is my Y1. So center of the fringe to the first dark area. Okay, so our equation is A sine theta is equal to P lambda. And we're interested in finding how wide is a slit. So we're searching for A. So I'm going to rewrite that as A, divide both sides by sine theta. So I get P lambda is equal to sine theta, or over sine theta is equal to A. So we don't know anything about theta, but we do know Y and L. So I'm going to use this triangle. Right, this is the triangle I'm going to use. And this is my theta. And so my equations, I'm going to use that for small angles of, say, theta less than 1 degree, then sine theta is about the same as tan theta is about the same as theta. And I'm going to use the fact that sine theta is equal to tan theta. So tan theta is equal to opposite over hypotenuse. So in our triangle here, red triangle, we're going to have that's equal to Y1 over L. And if I plug that in, my Y1, let's see, is I'm converting to meters, 0.12 meters over L, which is 2 meters. So tan theta is going to equal 0.006, make that a 0.6 meters. Or there's no, it's a unitless, right? Because I'm talking about tan theta. So let's see if I can erase. Doesn't look like my eraser is going to work today. Let's try that. Nope. All right, so I'll just cross that out, I guess. And so now if I plug in, so A is equal to P is 1 times 633 times 10 to the minus 9. So I'm converting nanometers to meters, divided by 0.006. When I solve that, I get, let's see, 0.000 106. Is that right? So let's see what I get. How many zeros do I get here? Just looking at my calculator for a second. Yes, so that's right. And I'm going to be, this is going to be in meters. My pen doesn't want to work again, so this is meters. So if I want to turn it into millimeters, 1, 2, 3, I'm going to have A is equal to 0.106 millimeters. And I'm going to do this problem again a different way. So we can just use one of the equations that you have. I can insert space and go down. So I want to use the equation W is equal to 2 lambda L over A. And we learned about that in the lecture that we had. So we're just going to see what we can do with this. We're looking for A. We know that, remember, I'll just draw this again. Remember that from here to here, from P equals 1 to P equals minus 1, that's going to include that big central peak, right? So this is going to be my W. So W is equal to 2y, right? So 2y1 here. So I'm going to say 2y1 is equal to 2 lambda L over A. So my 2's cancel. I'm solving for A. So what I can just do is just have A and Y1 switch places, right? So I can just swap them. So A is equal to lambda L over Y1. And I plug in 633 times 10 to the minus 9 meters times L is 2 meters divided by Y is 0.012 meters. And I get the same thing. I get A is equal to 0.000106 meters. And writing it in millimeters, I get 0.106 millimeters. So I can do that either way. If you get used to solving the double slit experiments, then you can do it the same way that you do. You just have to make sure you're going for the dark fringe for your p-value.